Hello. Today we're going to look at a curve sketching question. We're asked to sketch the curve y equals x over x squared minus 1. We're also given that y prime is equal to minus x squared plus 1 over x squared minus 1 all squared. And we're given y double prime. It's 2x times x squared plus 3 over x squared minus 1 all to the power of 3. Now, an important thing to keep in mind in the curve sketching questions is that just because we're given the derivatives, we're not necessarily given the factored form of the derivatives. As we can see here, in the denominator of all three functions, we have x squared minus 1, which is clearly factorable to x minus 1, x plus 1. We need to ensure that we factor each one of these. Otherwise, when we draw our sign diagrams, we won't have the proper information. Now, we're going to go ahead and evaluate the function at a few points. F of 0 will be 0 over minus 1, which is 0. So we'll get both an x and y intercept at the point 0, 0. Now, if we were to try and evaluate f of minus 1, we would find that the function is undefined, and f of 1 would also be undefined. Both of these will be vertical asymptotes. Now, we would also want to look and see what happens at infinity. Are there any horizontal asymptotes we need to be cognizant of? If we take the limit as x goes to infinity of x over x squared minus 1, we find that we get 0. And similarly, if we investigate the limit as x goes to negative infinity of x over x squared minus 1, we also get 0. So we're going to have ourselves a horizontal asymptote. We're also going to want to draw the sign diagrams of f, f prime, and f double prime. So here we have f, f prime, and f double prime. Now for f, we're going to have a root at 0. It's going to be undefined at, positive 1 and at negative 1. For f prime, we're not going to have any roots from the numerator, but we are going to have it undefined. Again at 1 and minus 1. And both of these are even powers. For f double prime, we'll have a root at 0. And will also be undefined at 1 and at minus 1. Now we want to pick a test value for each of these sign diagrams. For f, if we pick a large value larger than 1, say 10, the top will be positive and the bottom will be positive, giving us overall positive, negative, positive, negative. If we look in f prime, because of this negative sign here, if we pick a large value, say 10, we'll have a positive in the top, a positive in the bottom, but overall a negative. So f prime will be negative. Sign stays the same, negative, and negative. For f double prime, we can see if we pick a large value, 2 times 10 will be positive, positive, and positive. So we'll get positive, negative, positive, negative. Now we want to combine all this information to make a curve. So I'm going to, on the next slide, show us the sign diagrams next to the curve. So now we have in front of us our graph and our sign diagram. We want to label our asymptotes. And so here, we're going to have an asymptote where x cannot be minus 1. We're going to have another one where x cannot be 1. we're also going to have a horizontal asymptote. At y equals 0. Now that we have our asymptotes labeled, we can also put the point. Unfortunately, we only have one point to label on the graph, the origin. So let's go ahead and start drawing the graph. We can see here that the graph is going to be less than 0. It's going to be negative when x is to the left of -1. The graph is going to be decreasing, and it's going to be concave down. So we're going to have something in here that's got to be negative, it's got to be decreasing, and it's going to want to be concave down. So our drawing should look something like this. We want to approach the asymptotes, remain decreasing and concave down. Now in the next section, we know x has to go above the graph and then below the graph. So it's going to go from above the x-axis to below the x-axis. It's going to be decreasing the whole time, so that makes sense. It's going to go down here. But it's going to go concave up originally and then concave down after the point at 0. So when we draw our graph, we still want to make sure it's approaching the asymptotes. But we want it to come in concave up and then leave concave down. So ensuring that it looks concave up like a cup and then concave down like a frown. Finally, in the last section, it's going to be positive, it's going to be decreasing, and it's going to be concave up. So you would expect something that approaches the asymptotes that looks like that. So our final section of the graph should look like that. Now, often in a graph like this, we're asked to identify the domain and range. So let's do that as well. The domain. Well, if we look, what values of x are we not allowed? Clearly -1 and 1 are the only such values. So the domain will be -infinity to -1, union -1 to 1, union 1 to infinity. For the range, if we look, although y equals 0 is a horizontal asymptote, and although this section of the graph and this section of the graph do not pass the value of y equals 0, the middle section of the graph does. It crosses the horizontal asymptote because the definition of an asymptote just means that the function needs to approach it in the limit. And so it's perfectly okay to cross the horizontal asymptote here. And so we can see in the middle that the function obtains high values and low values. In fact, it attains all real numbers. So for the range, we can simply write -infinity to infinity. If we were asked to identify the inflection point, we would note that here we have an inflection point at 0, 0, because the concavity changes from concave up to concave down. So this is the overall method for sketching our graph. Thanks for watching.